Okay, we're on page 4 now, and we're looking at question 16. We're given these two functions defined, f and g defined as those. And part A says find f divided by g of negative 3. So I wrote this out over here. F divided by g of negative 3 means find f of negative 3 and divide it by g of negative 3. And if you plug in the negative 3 into the function, f is negative 2 plus x times negative 6 plus x, so there you have it. And the g is 1 minus 3 times x, so it's 1 minus 3 times negative 3. And that's just arithmetic. Be careful. Negative 2 plus negative 3 is negative 5. Negative 6 plus negative 3 is negative 9. Down here we have 1. Take away negative 9. So you got positive 45 over positive 10, which is 4.5. Or if you just reduce that fraction, you get 9 over 2. Now the second part, part B, says find all values that are not in the domain of f over g. And we can't divide by 0, so g is the denominator. We cannot allow g of x to equal 0. That means we can't have this expression 1 minus 3x equal to 0. If you solve that for x, you get 1/3 is the x value. That makes that 0. So here's the only number that's not in the domain. X cannot be positive 1/3. Okay? Question 17. Simplify this fraction, this rational expression. Clean up the numerator first. It's very easy because you got z to a power times z to a power. You got to add the powers, and even though they're fractions, you already have a common denominator. Negative 1/4 added to 5/4 gives you 4/4. And we'll leave that hang for a minute, that denominator. And z to the 4/4 is equivalent to z to the 1. And then it's the same old. Where's the bigger power? That's where it stays. 1 is bigger than 1/3. So we don't even have a fraction when we're done. It's going to be z to the power of this exponent minus that exponent. 1 take away 1/3. And of course 1 is equivalent to 3/3. 3/3 take away 1/3 is 2/3. There's our final answer, z to the 2/3 power. Question 18, it's a fifth root radical to simplify. So we want these exponents to be divisible by 5. And if you think about our old friend 2 to the 5th power being 32, and 32 goes into 96, convenient way to do this is factor the 96 into 32 times 3, since that's 2 to the 5th power. Perfect 5th power, and then take the variable parts. The x already has an exponent divisible by 5. The z was z to the 14th, so I make this z to the 10th, z to the 4th, making that divisible by 5 and as large as possible. And then this changes to a 2. This does not change. This changes to x to the 10 divided by 5 is 2. This changes to z to the 10 divided by 5 is 2. So these three are on the outside now. And what's still in the radical sign? The 5th root of 3, 5th root of z to the 4th. So there we go. 2x squared z squared, 5th root 3z to the 4th. That brings us down to question 19. And you could simplify this by itself and simplify this by itself and make a big mishmash, but since it's just a square root, if you try multiplying these together, right away you notice you get a 100, which is a perfect square, so that's handy. Multiply the w's together, you get w to the 13 and u to the 11. Well, here's what that looks like. 100, square root of 100, w to the 13th, u to the 11th. And then I'm breaking this up into little pieces, looking for perfect squares. So for the 100, that's a done deal. For the variable parts, they just need exponents that are divisible by the invisible 2 index. In other words, biggest possible even exponent. So w to the 13th, I split that into w to the 12th, w to the 1st. And here's u to the 11th split up. So that changes to a 10. This changes to w to the 12 divided by the invisible 2. U to the 10 divided by the invisible 2. These guys are still under the radical. So we have 10 w to the 6 u to the 5th times the square root of wu. And that's the end of this page.